Okay, now let's discuss the third one, which is a smoothing operation. Okay, for this one, I will like to ask you to open this file, which is smoothing.m. Okay, for smoothing.m. Okay, again, this is how we read the image or assign our image into a variable f, and then we display the image. And then for applying a smoothing, you have a two option to do it. Okay, there's a two option you can do. One is you can fully using the toolbox or the built-in function inside the Matlab. Okay, another way you can also use, you can assign or you can set your own kernels there. Okay, and then the convolution process happen actually, this is the convolution function IMFilter. Okay, and this is the input image, this is your kernels. Okay, so again, you have two options to generate your kernels. One is by using function called fspecial. Okay, fspecial is a function, a built-in function in Matlab that actually can provide you kernel without you think about what is the kernel inside. Okay, and you can try to search what is fspecial is all about. Okay, and then if you want to, again, if you want to operate, or if you want to execute the smoothing, one of it you can use is average filter. So that's why you in this function you just give the name, I want average filter, and this is the size of the filter. Okay, by default the filter size is 3 times 3. Okay, like we have discussed in the slide. And then if you run this code, okay, this is the how it generate, and this is the convolution mechanism, and this is how you display the output image. So if I run the code, okay, this is the your input image f, this is the output g. Okay, you can see the by having a by convolve with the 3 times 3 average filter, this one is a little bit blur as compared to this one. Okay, but the blurring effect is not so obvious because the size of the windows or the size of the kernel is very small, which is 3 times 3. But I want to highlight here is that our kernel here that produced by fspecial, if you double click, which is W, okay, you can see that this is the kernel, the generated kernel by fspecial, which is actually is 1, or if you divide 1 over 9, you also get 0.1111 something. So this is the kernels. Okay, so that is if you are using fspecial. But if you don't like what have been provided by the fspecial, you can also run it manually by providing the matrix like this one. Okay, this one. So actually this is also 3 times 3 average filter. So you provide this one, and then you declare or assign this matrix with this variable W, and then you execute this one. You also get the similar output there. Okay, this one is more blur than this one. Okay, but the good things about fspecial, okay, again, like I said, if you don't do, okay, by having manual something like this, if you increase the size, then you need to type very huge metric elements there. So that's why it's better for you to use fspecial, because fspecial you can increase this size by having this one. Because for example, you want the same average filter, but I want to increase this one. Instead of 3 times 3, I want to use 5 times 5, 7 times 7. Okay, let me use here 11 times 11. So what happened, because what we have discussed before, the larger the size of the average filter, the effect of the blurring effect will become more and more obvious. So if you run the code, then you can see now, okay, the blurring effect is more and more obvious. The things that I would like to highlight instead of this one is this thing. You can see at the borders there, it become very black. So that's why, like I said before in our discussion, for our hand calculation, the one at the border, the pixel at the border, actually we always set into 0. But in Matlab, there's a some mechanism how they handle the pixel at the border. Okay, they have their own solution. But for your hand calculation, you can just set it into 0, because that is also happen at the simulation. Okay, when you increase the window size, the kernel size, then more and more pixel at the border is not processed. So that's why that's why when I increase the size of the average filter, now the white line here, the black line here become more and more obvious. Okay, you can see that let's say I try to do it with, let's say, 55 for example. Okay, then you can see that become more and more blur, and this line become and more obvious, because now the more pixel at the border is not processed. Okay, it has been ignored by the convolution mechanism.